Good evening, everyone. This is presentation by Group 3 on factors that influence trustworthiness of AI-infused decision-making process. We know that data scientists are training AI-based models that help provide recommendations to human decision makers in a variety of domains. Many decision making procedures, including jail sentence recommendations, college admissions, etc., has begun to integrate with the help of AI components. AI models are being educated to assist humans in all of the scenarios. Decision makers make accurate and fair decisions, but little is known about how they do it. From this presentation, we will know about different aspects of decision-making process, how an AI model supports that process and people's perspective of trustworthiness in this process. This paper also answers a set of questions like who owns responsibility for the final decision, AI or human? Is the model interpretable, making it easy to understand, and why it made a particular recommendation, or is it a black box that gives no information about how it made its conclusion? This paper is based on six factors, which are decision stakes, decision authority, model trainer, model interpretability, social transparency, and model confidence. We have many definitions of trust. One that is easy to understand states that trust is the attitude that an agent will help achieve an individual's goals in a situation characterized by uncertainty and vulnerability. One of the greatest challenges facing research in the area of trustworthy AI is to precisely define and measure trust and its role in understanding relationships between people and machines. Much of the prior work on measuring trust in automated systems have focused on evaluating the trustworthiness of the decision rather than evaluating the trustworthiness of decision making process itself. From all the research, they have concluded that trust must be examined in a multidimensional way. Primary research question is to identify how different aspects of an AI infused decision making process influences people's feeling of trust in that process. They have examined the following factors to determine the shape of this boundary. Stakes. Stakes are used to describe the ramifications of choice that has been made. Both lower and higher stake decisions are made like meal planning in the case of lower stake decision and jail sentence for higher stakes decision. Decider. It answers the question that who is in charge of making the final decision. Contrast choices are compared which are made purely by AI with those made by human with AI assistance. Trainer. It helps which method was used to train the AI. We compare AI models taught by human data scientists to those trained by automated AI. Model interpretability. Decision trees and rule based scoring systems are examples of interpretable AI models. The method through which interpretable model arrived at a suggestion may be analyzed and understood. Other models, such as deep neural networks, are termed as black boxes since the inner workings do not reveal how a suggestion was made. Train and test set description. It focuses on an explanation of how the model was developed and tested. Researchers and other promoters of AI fairness have asked how AI models are developed so that many people may access their trustworthiness. Social transparency. It focuses on observing how a model makes judgments for other individuals, which might reveal whether or not it is biased. Model confidence. It focuses on generating a suggestion. Several AI models have the capacity to offer an estimate of their confidence. To evaluate trust in AI infused decision making, we will use the factors that were mentioned earlier. There will be 128 unique combination, 2 of stakes, 2 of decider, 2 of trainer, 2 of interpretability, 2 of train and test description, 2 of transparency, and 2 of confidence. 362 people were selected, and criteria was that they should be 18 years or older and speaks English fluently. Let's discuss examples of higher and lower stake scenarios. This example is about high stake scenario. When a person is found guilty of a crime, the length of their sentence must be set. Here's everything you need to know about the process for determining a jail sentence. An algorithm will totally determine the length of the prison sentence, so decider will be AI in this case. The AI model was created using historical data on crimes and prison sentences without the need for human participation, so trainer is automated AI. By looking at the model, you can figure out why a choice was made and what elements went into making that conclusion, so model is interpretable as well. Information regarding the data used to train the model will be made accessible, including where the data originated from, how much data was used for training, and how much data was used to evaluate the model's accuracy. So, we can say that train and test description is also present in this case. Information concerning additional offenders' jail sentence recommendations will also be made accessible. So, transparency is also present, and information on how sure the AI model is in its recommendation for jail sentence will also be provided. So, confidence is also present. Let's have a look at this examples of low stake scenario. A meal plan must be developed for a meal service customer. Here's what you already know about how a menu will be put together. A chef will utilize an AI model to assist with planning, but chef will make the final decision. Here, decider will be human. A group of data scientists develop AI model which was trained using previous data on meal choices and nutritional information. So trainer will be human in this case. One cannot understand why a choice was reached or what variables were employed in reaching that conclusion by looking at a model. So interpretability will be black box in this case. No information on the source of data used to train the model, how much data was used for training, how much data was used to evaluate the model's accuracy, or the model's accuracy will be made accessible. So, train and test set description is absent. Information regarding other meal plan suggestions submitted for other customers will be kept private. So, transparency is also absent. And there will be no information accessible regarding the AI's confidence in its meal plan recommendation. So, confidence is also absent. Now, I shall pass to Ayush for analysis of trust factors.
Hello, I am Ayush, and I will be continuing with the paper in AI with trust factors that influence trustworthiness of AI-infused decision making process. The next topic is analysis of scenario factors on trust facets. They performed several kinds of analysis to determine where the boundaries of trust lay amongst the different factors. First, they conducted confirmatory factor analysis to ensure the modified versions of the scales for reliability, technical competence, understandability, and the personal attachment continued to exhibit the high degrees of reliability. They also conducted exploratory analysis on the scale of trustworthiness to ensure each item measures the same underlying construct. All scale exhibited a high degree of reliability except understandability. Next, they computed outcome scores for each scenario for trustworthiness, reliability, technical competence, and personal attachment. Then they used ANOVA model to understand the relationship between the scenario factors and these trust outcomes. Finally, they performed a qualitative analysis to understand responses to their open-ended question about trustworthiness. By mixing qualitative and quantitative methods, they aim to provide a more holistic picture of how each scenario factor affected trust in an AI infused decision making process. Factor analysis indicates that the trustworthiness scale had high level of reliability. In addition, confirmatory factor analysis indicated that although they had a drop or rewarded items from the existing scales of reliability, technical competence, and personal attachment, these scales remained highly reliable. They constructed an ANOVA model to test for main effects and all two-way interactions of the scenario factors to understand their effect on trust. As participants provided ratings of two scenarios, They included participant ID in the model as a random effect to control for this repeated measure. When presenting ANOVA results, they report effect sizes using partial n-square, which is the proportion of variance accounted for by each of the main effects or interactions in the model controlling for all the other effects. They represent ANOVA results for all main effects in the table given below. However, for each of the trust facets, two interaction terms were consistently significant: decider cross-trainer and decider cross-confidence. Therefore, we focus our analysis first on the non-interacting factors: interpretability, train test descriptions, and then around the interacting ones. This table describes the effect of scenario factors on trustworthiness. Only main effects are shown, although significant interactions were present between decider, cross-trainer, and decider cross-confidence for each of the trust facets. Due to the inclusion of a random effect, degrees of freedom are fractional and vary for each factor. Bold text indicates significant and medium to large effects. Moving on towards individual trust facets. First is stakes. Stakes exhibited significant and large effects on trustworthiness, technical competence, and personal attachment. The use of AI in lower stakes scenarios versus higher stakes scenarios was associated with higher trustworthiness, higher technical competence, and higher personal attachment, shown in Table 1. In their own words, many participants expressed having less trust of AI in higher stakes scenarios. Ratings of reliability did not differ between the lower and the higher stakes scenarios, indicating that participants may have felt the AI system described would produce consistent results irregardless of the stakes of the decision being made. Next is model interpretability. Interpretability exhibited significant and strong effects on each of the trust facets. Interpretable models were consistently preferred over black box models. They were rated as more trustworthy, more reliable, and more technical appropriate than black box models. And participants liked the decision process more when they used interpretable models. Many participants expressed concerns over the use of black box models. Although the statistical interaction was not significant, one participant did not comment on how the use of interpretable models may be more important for higher stake decisions. Train and test set description. The presence of information about how a model was trained and tested had significant and strong effect on the ratings of trustworthiness, technical competence, and personal attachment. Decision-making process that included the information were rated significantly higher than the process that did not include that information. The desire for transparency in how AI models are trained was discussed by many participants. Moving on to transparency, the availability of information about decisions made for others had a significant but small effects on 4 trust facets. Decision-making process that included this information were rated higher than the process that did not include that information. This desire to know what outcomes an AI-infused decision-making process produce for other people was clearly expressed. Next is decider. Participants expressed mixed opinions towards who makes the decision in the scenarios, a human or an AI. Some felt comfortable with an AI making the decision as long as that process was transparent. Other participants expressed preferences for having an AI make the decisions due to it being free from human biases. Conversely, some participants expressed concerns over trusting an AI to make the decisions because of their lack of empathy. The next is trainer. Participants generally expressed a preference for an AI model trained by data scientists rather than the models trained using the automated methods. There was significant but very small interaction between decider and trainer for trustworthiness, technical competence, and personal attachment. When the decider was an AI, all 3 facets were rated higher when humans were responsible for training the AI than when automated technologies were used. Thus, participants favored human-trained AI when that AI is solely responsible for making a decision. When the decider was a human, there was no reference in trustworthiness or personal attachment based on how the AI was trained. But participants did feel that human-trained AI was more
Hi, this is Yesha on this side. So, black boxes are less trustworthy. How can we say that? Because the decisions which are made in black boxes are automatically. So, by that, it is hard to explain what decisions are made in black box. For human, they can only adjust the black box mostly on a development side. So, to to avoid the use of black box in AI, the interpreted models are establishing trust to give the higher stake decision than a lower stake decision. So from this paper, it is highly recommended that interpreted models should be used instead of black boxes where it should continue with a higher stake decision based on that it will cover the guidance of lower stake decision which can be made by the black boxes. Mitigating human biases. So, historical data often carries biases of which we may not even be aware because of the existing human and systematic biases present in the process that produce that data. The danger of using historical data to train AI was captured by P100. Many participants expressed such concerns over training on biased data, especially for higher stake decisions. For discovering process, we have a four processes which is building, planning, deployment, and monitoring, which have all the things which can be used to building the trust or trust on the AI system for humans. So, these sentiments reflect the need for specific steps to be taken when training AI systems to mitigate and minimize the impact of such biases. So, to discovery the trust on AI model, that should be the explanation, optimization, generalization, right to contest, oversight, consultation, representative data, abusability, privacy, and discrimination. All this can be used to mitigate the human biases and it can discover the trust for human on AI models. AI's lack of empathy and morality. With the help of empathy in AI system, artificial emotional intelligence can allow us to take the first step towards functional artificial general intelligence that will empower the humankind, which gives the empathy to feel the emotions of the humans by machines. So, secondary, the AI machines lack certain moral qualities that seem to be important in the provision of healthcare, such as trustworthiness as well as the ability for empathy and compensation. Limitation and future direction. First, how AI is being incorporated in decision making process where AI is not able to make the decision properly because it making the decision automatically. Second, faulty assumption, which is very difficult to understand how to trust on AI model by humans because if it is giving faulty assumption, it is not trustworthy. Third, AI infused decision making process which gives the infusion of thoughts on process of humans to get trusted on AI models. Fourth, numerous number of algorithms to explain black box where humans are not able to understand how to trust on black box because sometimes it's showing that we should trust on black box. It is 100% correct, but on the other hand sometimes it is showing you should not trust on black box decisions because it is not true. Two, future direction which can make the AI world easier in future. First, ability to explain how to build trust on AI model, where human can trust on AI model by giving some assurity from by taking some assurity from AI machines. Second, to trace and train the AI model in higher level, which gives 100% surety that AI model will be the true 100% true and trustworthy. Conclusion: with the growing usage of AI and machine learning models in making decisions that significantly impact our lives, the need to understand how to build trusted AI is paramount. It seems inevitable that AI systems will become a larger part of the decisions we make and the decision made for us in our lives. Whereas this paper has found how an AI model was trained and tested are associated with significant improvements to people rating of trust.